Okay, so continuing on with these 89 factoring problems, we're going to look at number 34. So for number 34, we have 2x to the fourth minus 16xy cubed. So again, with a question like this, you're going to want to always look for GCF, and I can see here the GCF of this is 2x, in which case we get x cubed minus 8 y cubed. Now, if you look at this here, we have what's set up here is it's set up for a difference of cubes. So with a difference of cubes formula, if you remember, the difference of cubes formula is x cubed minus y cubed is x minus y, x squared plus xy plus y squared. So that's the difference of cubes formula. So I have to rewrite this as a power of 3, which it already is. And I can rewrite this as a power of 3. And then once you do that, I can go ahead and apply my difference of cubes formula. So this will factor into 2x times x minus 2y times you're going to square the first term, multiply the first two terms together, making them positive, and then square the last term. And now you guys will see here that I have my factored form. Okay, so I use the difference of cubes formula there. All right, let's check out 35. So for 35, 125a cubed minus b cubed. Again, setting this up for a difference of cubes, I can write this as a power of 3. This is already written as a power of 3. And now, fairly clearly, we can go ahead and apply my difference of cubes formula. So you're going to square the first term, multiply the first two terms together, make them positive, and then square the last term. And again, we have here a factored form. Okay, let's look at 36. So for number 36, here we have a cubed plus 27. And again, you want to write this as powers of 3. And this becomes a sum of cubes formula. So the sum of cubes formula, if you'll notice, looks like this: x plus y, x squared minus xy, plus y squared. So in this case here, this becomes a plus 3 times a squared minus 3a plus 9. And now we're factored again. Okay, so there's 34 to 36. All right, let's take a look here at 37. So 37 is 4a cubed minus 4. Again, whenever you're factoring, you always want to look for a GCF. I'm going to factor out that 4 here. In which case now, again, I'm set up for a difference of cubes. And this will factor into a minus y. You square the first, multiply the first two, and square the last. And now we have 37. Okay, so now we're going to look at number 38. If you look at 38 here, it's a little more interesting. What do we have here? 38 is a minus b cubed plus c cubed. So we want to factor this here. Okay, just to remind you again, x cubed minus y cubed is going to be x plus y. X squared minus xy plus y squared. So if I want to factor this one here, we're going to have what? Well, this is going to be a minus b. So it'll be my x plus y times, you're going to square the first, and then the product of the first and the second. And we've got the product of the first and the second here. And then plus the last term squared. So looking at this here, We can drop the brackets on the a minus b. That doesn't affect it at all. I would probably expand this out here, so just to see if there's anything we can simplify inside. So if I square the first to get a squared, first times second times 2, square the last. I can distribute that c value, so it becomes minus ac plus bc plus c squared. Now at this point here, I don't really see much more you can do inside of the brackets here. You can take a look and see, like, is there a way I can combine these together so that you get some nice factoring that happens throughout, and I don't see that with this question here, 38. So this would be the final form for number 38. Okay, moving on here. 39 is x cubed minus 216y cubed. X cubed minus 216y cubed. So again here, you're going to do your difference of cubes formula. So if you take a look and take what is the cube root of 216, you'll find that the cube root of 216 is 6. So I can rewrite this as 6 cubed. So now I have my difference of cubes formula, x minus y, x squared plus xy plus you square the last term. And we're factored. Right. Number 40. Again, I encourage you to pause the video, try these questions out on your own, and just see how it flows from there. Okay, this is an example of a sum of cubes formula. You just have to adjust the formula so you actually have it expressed as a sum of cubes. And you'll notice just using just your basic exponential rules here, power to a power you multiply, I can rewrite this as now a sum of cubes. So as a sum of cubes, this will be x plus y times you square the first, the product of the first two with a minus sign, and you square the last. And doing that here, we now have number 40 factored. Okay, there's 39 and 40. Let's take a look here. We're moving on to 41. So number 41 is n to the 6 minus 1. So again, this would be an example of a difference of cubes. So I'm going to write this like this form. So I can apply my difference of cubes formula, and this would be n squared minus 1. Then you're going to raise that to the power, you're going to square that, take the product of the first two, but it becomes addition, and then you square the last term, and 1 squared is 1. Now you notice here we can do a little bit more. I have a difference of squares sitting here, so we can break this up into n minus 1, n plus 1, n to the 4th plus n squared plus 1. And now this is fully factored, this example here. Okay, 42 is x to the 6 minus y cubed. So number 42, x to the power 6 minus y cubed. So again, you want to set this up as a difference of cubes. And this becomes your x minus y times you're going to square the first. Product of the first two with a positive sign, and then you square the last term. At this point here, there's not much more to do with this question. If you take a look, I don't see much more that can happen with number 42. And then we have 43 is 16a cubed plus 54b cubed. A cubed plus 54b cubed. So let's just double check that, make sure I got it right. 16a cubed plus 54b cubed. So now, same idea here. You want to write these as powers of 3 if possible. Now, if you go ahead and take the cube root of 54, there is no cube root of 54. Like, you can't write 54 as a power of 3, and likewise, you can't write 16 as a power of 3. But I can divide out a 2 out of this whole expression, GCF out of 2, in which case I'm left with 8x cubed plus 54 divided by 2 is your 27, and now you would probably recognize these as both being powers of 3. So I could rewrite this as 2a quantity cubed plus 3b quantity cubed. And now I can go ahead and do my sum of cubes formula, in which case it'd be x plus y times you square that first term, multiplication of the first two with a minus sign, and then you square the last term. Okay, and then you're in this situation here. Now, it might be worth it to look here. Sometimes you should check to see whether this factors. Oops, sorry about that. This one doesn't factor. It's very close to factoring, but it does not factor. If you wanted to, you could actually force an incomplete square that we talked about earlier. Again, that's a previous video, so you can check it out. We talked about this idea of incomplete square. You can actually force an incomplete square here, but your roots would be a little bit rough, and I would just leave it like this. It's not any clearer or any more factored than it was before, but technically you could force an incomplete square. Okay, so there's 43. And now we're going to look at 44 as x cubed minus a minus b. So this is 44 as x cubed minus a minus b cubed. So for something like this, it's already set up as a difference of squares. So you can go x minus y. Don't forget those brackets. And you're going to square that first term, the product of the first two terms, and then you're going to square the last term. Okay, so let's check this out, see if anything happens inside. I'm going to distribute that minus sign. And then I'm going to go ahead and distribute that x. So we're going to get plus ax minus bx. And then lastly, I'm going to square this term here and see if anything comes about with the factoring for this one here. Looking through this one here again, I don't see. Okay, moving on to number 45, it's going to be x to the power of 12 minus y to the power of 12. So you want to write this as a difference of cubes. Would be one way we could start this. So to write this as difference of cubes, keep in mind the power of 3 has to be on the outside. Right? The power of 3 has to be in the outside. So now if I use my difference of cubes formula, this would break up into x to the 4th minus y to the 4th times you're going to square that first term, the product of the first and second with a positive sign, and square the last term. Now here you'll notice right here I have a difference of squares here. So I could rewrite this as x squared minus y squared times x squared plus y squared. Now with this one here, you can approach this as an incomplete square, and that's something I've talked about in a previous video. And how incomplete square works is it would be nice if this was the case. Right? It would be nice if x to the 8th plus x to the 4th y to the 4th plus y to the 8th was actually equal to this, but it's not. If I expand this all out, if you square the first, you do get your x to the 8. If I square the last, I do get my y to the 8. But if I do first times second times 2, I'm short 1 unit of these here. So this ends up kicking out a 2x to the 4th y to the 4th, so I have to subtract off and x to the 4th, y to the 4th out of here. Now, the advantage to that here is I'm just going to quickly notice here I have a difference of squares again, so I might as well write that out. The advantage to that is now I can go ahead and do a difference of squares inside here, and by doing that, you would have this factored. So check this out. This would become my first minus the second times the first plus the second. Okay, and it would be worth it just to clean it up a bit. So clean this up here. We have x minus y, x plus y, x squared plus y squared, and then x to the 4th minus x squared y squared plus y to the 4th times x to the 4th plus x squared y squared plus y to the 4th. All right, and taking a look here, there you go. You have your fully factored expression here. So x to the 12 minus y to the 12 will factor into this right here. Okay, that's one way you can do it. Another way you can do it is, instead of going through this method here, what we could have done, and it actually might have been a little bit easier, is instead of doing a difference of cubes first, you could have started off with a difference of squares. So you could start off this question. I'll leave it to you guys to try it out. You could go ahead and start and write it out like this, and then go through the process that way. All right. Thank you.